Hi everyone, and welcome to another Platformers live stream. Today we are going to do a deep dive on Inspektor Gadget, a really cool eBPF-based open source project. And with me today, co-hosting is the wonderful May.
Yeah.
May, do you want to quickly introduce yourself and our guest?
Yeah. So hi, as he said, my name is May. I am a senior platform engineer at Porter. And I wanted to say that I love Kubernetes, but I guess it's kind of weird. But I can say I have feelings towards Kubernetes.
It's complicated.
It's complicated. I think this one is it's the best way to say it. So yeah, that's me. Dov, Amit, do you guys want to introduce yourselves? We have both Dov and Amit here today. I guess you guys can do it better than me. I just want to say that they're both so wonderful. I just can't wait for this to start. But that's it. I'm going to shut up now.
Like,
also,
yeah. Okay, so my name is Amit. I work at ARMO as a security researcher, and I'm also a Kubescape maintainer, which is also an open source CNCF project. When we are using Inspektor Gadget a lot, so I'm really excited to talk about this project with Dor.
Hey everybody, I'm Dor. I'm joining you from Microsoft, specifically working on Microsoft Defender for Cloud, and very deeply focused on container security. And yes, Defender for Cloud, we're also using Inspektor Gadget. So that's where I'm familiar with. I think we can get started, no? Or would you like to chat a little bit more?
So thanks for the intro. Thanks for joining us today, Dor and Amit. And let's get started. But for those who may have never heard of Inspektor Gadget before, or only know Inspektor Gadget, the context of the cartoon, maybe you can tell us a bit about what is Inspektor Gadget really?
So the TLDR would be the Inspektor Gadget is a way, it started as a way to debug and troubleshoot your Kubernetes clusters, but since it had evolved, I think about like 1 year ago, we see the project like changing into something very exciting, which we will go into as part of this session. It's eBPF based, so it gives you all those observability and then tracing capabilities around Kubernetes and containers. And what's really cool about that it's very container aware. Like that's how it's different that other eBPF debug tools. So that's what really is cool about that. That would be the TLDR. But yeah, there's a lot to cover. So unless there are any outstanding questions, I think we can start, right?
No, let's start off with the niceties. Let's dive in. Come on, now is the time.
Awesome.
Yep, so it's Inspektor Gadget Deep Dive. We've introduced ourselves. So Dor, you want to get started?
Yep, so I think, like talking about Inspektor Gadget or any other eBPF tools, like it would be a crime in certain circles to not talk about eBPF first. So a question to the crowd here. You're probably heard of Cilium or like Falco or other eBPF products, and I'm wondering like what is the crowd currently using? What kind of like eBPF products are you using today, and so on. So, but with that, let's go to learn what eBPF is before we learn about Inspektor Gadget. So back to you, Amit.
Cool. So I guess as you're probably familiar with the kernel development, so you all know that putting like and inserting a new feature into the kernel can be a hard work and a very time-consuming work. And this is like a really funny comics from Isovalent, where you can see like an application developer that wants a new feature into the kernel, and it eventually takes 5 years to put it inside because of all the checks and all the verifications, and everyone needs to take a look and approve it. And eBPF basically kind of did a revolution in that manner, because with eBPF, and we're going to deep dive into understand how eBPF actually works, but eBPF makes it so easy to put new features and like create new plugins for kernel and basically extend the functionality of the kernel. And with eBPF, it can be a matter of a couple of days to create a new feature. So for those of you who are less familiar with eBPF, let's do a quick introduction, and then we're going to do the deep dive into Inspektor Gadget. So what is eBPF? Basically, you can think about it the same as you always describe APIs, with that you have a restaurant and the waiter and the kitchen. So you can think about it as the user mode processes that, and maybe it's your application. Let's say your application, as we see in this image, wants to read or write data into a file. So your application eventually is going to perform a system call, which is going to request from the kernel, please write this information to this file. And eBPF basically allows you to put a hook inside many different subsystems inside the kernel. So for example, you can put it on sockets, on the virtual file systems and network devices, and many different places. So if we're going back to the analogy, it's like you can put a hook on the waiter that takes your order on its way to the kitchen. And you can also put hooks on the kitchen, and you can put hook on the client. So basically, you can put hook in user mode, and you can put hook in kernel mode. So it's really flexible and gives you a lot of powerful mechanisms. And this is why we see it is so widely spreading in the recent years. So let's go a bit deeper into the way eBPF works. So eBPF actually, it's not running natively as other C or CPP programs that you can compile. Basically, eBPF has its own instruction set and its own registries, and eventually it's running in, you can think about it like a sandbox inside the kernel. And this sandbox basically knows how to digest the different instruction set, convert it back to the architecture below, let's say it's ARM or x86, and basically run your code. But the unique thing is that before loading an eBPF program into the kernel, you're going through a lot of checks. So let's go with this image over here. So we have an eBPF program. We compile it to the special bytecode instruction set that we've talked about that is special to BPF. Then this BPF is basically your program. Now your program is going to be loaded into the kernel. Behind the scene, it's using the BPF system call, but now you have a lot of wrappers. You can use it like you can write a Go program or a C program that will actually do the system call for you and load the program into the kernel. Once it's being loaded with the BPF system call, it's going to, before it's being actually loaded, it's going to pass through a very important component called the verifier. And the verifier, it's like one of the biggest magic of eBPF, because maybe some of you heard that eBPF is really safe to use. And a lot of it's because of the verifier. So the verifier verifies that your program is safe to use. And what it means is that it has a lot of different conditions. For example, it checks that you don't, your program always have an ending, so you don't get into infinite loops. It checks that you don't pass certain stack size, that you don't pass certain instructions counting, and it does a lot of checks, and it's like a big complicated piece of code. But after you pass the verifier, like there is this JIT compiler. Basically, eBPF runs JITed into the kernel. It can run non-JITed, but most of the time it's going to be run JIT mode, and then it's going to run in this sandbox.
Amit, I gotta stop you for a second there. You were talking about security and safety, and I think I'm not the only one thinking this, given recent events. Hug ups to everyone from CrowdStrike listening in. But all this looks like super fragile and like a recipe for disaster. Am I wrong to think that?
Yeah, so we all probably heard of the event with CrowdStrike causing millions of computers to go blue screen, and this is like, and I also saw a lot of posts about people saying, oh, this is why we need eBPF, because it's not going to happen in eBPF, and it's actually true, because in Windows, for example, when you load the driver, and even in Linux, when you load the driver, a kernel component, let's go backward. When your application in user mode or crashes, so the kernel is the one responsible for handling the crash for you, so that your computer won't freeze. But in kernel mode, when you and your operating system are running on the same level, there is no one to handle that error for you. So in Windows, for example, when your driver gets an exception, the entire computer crashes, as we saw with CrowdStrike. But with eBPF, it's less likely to happen, because with eBPF, you have this verifier component that actually verifies that your code is not going to crash, or it's not going to crash the operating system. And this is why eBPF is actually really good in that manner. For like if I were a CISO, for example, and there is a security product that wants to be installed on all of my machines, I can go sleep with my head clean that all the workloads are not going to crash, because eBPF is safe. So this is like one of the main reasons also eBPF is gaining a lot of momentum. And
okay.
Yeah. So
is there a
the last
reason to, just one small question, is there like a reason to prefer kernel models after all? Is like any like some power in it that is not possible with eBPF, maybe hasn't been developed yet or something like that, which might cause people to still go with kernel models?
Yeah, so that's a good point. And we still see some companies still afraid to do this shift to completely go to eBPF. And so in eBPF, you have a lot of limitations, right? So the verifier and other components of eBPF and the design of eBPF, it's quite limiting. And the Linux maintainers of eBPF are doing a good job in extending the capabilities of eBPF. We can see that, for example, just in the recent conference, they talked about that you can plug in your own custom scheduler above eBPF, and now you can perform LSM with eBPF. You can do a lot of things, but you still have limitations. For example, like the biggest limitation, for example, for a security product, is that you cannot write to any structure that you want in kernel. You basically even cannot modify anything in the kernel, in contrast to kernel modules, for example. So it has its pros and cons, but overall, I think for most use cases, it fits really well.
Okay, I guess in a lot of cases, you should go with the more limited one, because it ensures your security. And I guess unless you really, really know what you're doing, but I guess that some people also thought that they know what they're doing. That's right.
Yeah, doing it on a Friday, that takes a lot of confidence.
So if you let me chime in for a second. So I think that from observability perspective, eBPF is like, it had evolved to a state where it's very, very convenient to use over kernel modules. So yeah, while there are some limitations in changing stuff within the kernel, which is like more, I would say, more connected to security scenarios and so on. For observability, for debugging, for tracing, I think eBPF is very, very mature. But we do see eBPF keeps on evolving, right? Like there was this session in the latest KubeCon where the folks from High Valent showed how they ran, like this really large chunk of eBPF program, and you see it's evolving. So I think we're very, very good. Today is a very good place to start using eBPF.
Yeah. So let's finish the introduction with eBPF. Just one last thing that we need to be familiar with before jumping into Inspektor Gadget. So in eBPF, there is an important component called maps. And maps are basically global kernel objects, and your eBPF program can use them. And I think they're important mainly for two reasons for now for us to understand. The first one being that your stack size in eBPF is really small. So for example, when you write eBPF code and you want to create a variable, like you do in your Go application, for example. So if you create a variable that is can be quite large, basically you're not going to be able to load the eBPF program. And maps are a way to store bigger objects, basically that are not going to be stored on the stack, and that way you can use them in your program. And the second thing is that maps allows you to communicate with the user mode process. So for example, you have the eBPF program sitting in the kernel, and then you have like the agent in user mode that is talking to the eBPF program, and this communication is done using maps. And there are special kind of maps for this communication. The most, I'll say, common or famous or easy to understand is like a ring buffer. So you can create a map of a ring buffer type, and then basically perform this communication over this map. And I think that's enough introduction for eBPF. And let's just go to Inspektor Gadget, right? So Do.
Yeah, so I think a really good way to get to know Inspektor Gadget is by doing. And as I told you before, Inspektor Gadget started as a debugging, as a observability kind of project. And I have a question for the folks here at home. What's the most annoying thing about troubleshooting on Kubernetes? So for me, it's troubleshooting DNS. I think like that's a very common scenario, right? There's this haiku I love. I think it was created when the internet was born. I know it for quite some time now. But when you troubleshoot DNS, right? So on Kubernetes, what would you typically do? You would probably look at the application logs. You would try to start an interactive shell, right, on your container or on your host, and try to dig that up. Or you could use observability tools, but if you lack those, so probably that's an overkill. You should have those, but I wouldn't do that. You could also spin up a debug container, but that doesn't really give you the same kind of like application that you're actually running and trying to debug. So I would say that it's not the best way to actually debug DNS issues. And if we go into not only not being able to resolve stuff, but let's say I'm having trouble with DNS latency, right? So let me quickly share my screen to show you how can I use Inspektor Gadget to check the latency of my resolved DNS calls. So on the right over here, that's where I'll run my containerized application on my Kubernetes cluster. Let's see that. So that application would be, in this case, just an Ubuntu container. So I have my trusty Ubuntu over here. Let's just do kubectl get pods. Let's start just a shell over here, which will act as my application at this set. So that application is going to do some, like network calls to several DNS calls, to several DNS records. But let's do this command over here, which is Inspektor Gadget to trace DNS calls. And what this specific command does, it listens to all the DNS events that did not result in an error, and we log only events where the latency was over 20 milliseconds. Okay, so let's start tracing DNS events. And over here, let's do curl to google.com. So like going to Google, I would have expected that it would be less than 20 milliseconds, right? But if, for example, I would try to go to royalmail.com, which is the postal services of the United Kingdom, I can see that the latency is much higher than going to Google. So you saw for Google, for example, I did get a record. I'm not sure if it's for the request for response because my screen is is zoomed in. But most probably, if I'll go to Google again, it won't log anything. Yeah, if I go to, let's say, I don't know, japan.travel, because if you want to book a train in Japan, right? So that's the way to go. So you see the latency is higher. So that's a really cool tool without installing anything, without changing the container, I was able to actually get data about DNS events that are happening within Kubernetes. And as you can see, you can also get the container context and the Kubernetes context about where the event originated, from what Kubernetes node, from what namespace, from what pod, from what container within that pod. So you get all the data, and it's pretty exciting.
I think what's good about it, if I may, I think what's good about it is that if you're encountering an issue, the most tedious thing is to start, looking around and starting to decide which container, which node, which one should I start with, where should I go? And this way, you can just start poking around without going into too much effort, which is what I find super useful in this case specifically.
So exactly, and right here, I do the trace DNS, and my Kubernetes cluster only runs the single Ubuntu container, but actually it listens to all containers on my cluster across all worker nodes, right? So if I had a big system and I want to trace DNS across my cluster, that's a really good way to do that. And also, Inspektor Gadget gives you a really neat way to filter out specific containers. So that way you can also focus on a specific container, or just exclude a specific container. So that's really, really neat. So I think we have a really nice understanding of what's going on and how we can use Inspektor Gadget to debug stuff. So I think a really good way to understand a project is by going to its GitHub page. Let's leave the presentation. Let's go straight to the GitHub page. Let's read the README. So the overview goes Inspektor Gadget is a collection of tools, which we like to call gadgets, to debug and inspect Kubernetes resources, but not only Kubernetes, by the way. Also your Linux, or just a host running containers. And it also manages the packaging, deployment, and execution of eBPF programs. Once again, gadgets in a Kubernetes cluster or Linux host or whatever. Many of the built-in gadgets that are shipped with Inspektor Gadgets were inspired by the BCC project, which is the BPF compiler collection. And if we go back to what Amit told us about eBPF, so we can see all the different subsystems and what gadgets hook to what subsystems. Okay. So over here, there's a description of all the different gadgets that Inspektor Gadget give you out of the box. Stuff like generating SecOp profiles, stuff like kind of top capabilities also for eBPF. If you want to trace, so you saw the trace DNS a while ago. Stuff like FS Slower, which allows you to trace slow file system events. Lots of different gadgets. I won't go into detail for each one of those, but let's keep on. I really invite you folks to to explore the documentation, see how you can use the different gadgets. It's really, really exciting. So for the installation, there are different different form factors you could use to install Inspektor Gadget. I think the best way to get started is to actually use the Kubernetes kind of form factor as described here in the README. But you can also use it as a binary. You could also use it as as a library. I think the folks at ARMO, Amit, right? So you use it as a library. You'll probably see that later. We do have that all the time. And so it's really, really flexible in how to get started. But there are a lot of neat things that the Kubernetes installation solves for you. So let's look at the help section. So at the help section, you can see all the different commands you can use. Nothing really new, but I think there's one command here, which I would like to focus on, and that's the only hint in the documentation for this shift that Inspektor Gadget is going through, and that's the run command. So you can see it's marked as experimental. I think that are going to drop that very, very soon. And it says run a gadget, okay? Now, the folks at Inspektor Gadget, so they built lots of gadgets, as you can see. And they came to a realization of how do you build an eBPF program? How do you make it container aware? How do you deploy to the cluster? And they solved all those bits and bytes that relate to actually, making sure that you can run your gadget on top of a cluster. And, they sat down and they thought about that and said, hey, we actually built a framework, and that's true. Like, we can use Inspektor Gadget to actually build gadgets by ourselves, and that's where the project has been evolving to. That's the way I see that, at least. Or looking at the latest talk on rejects, you can see one of the product managers from Inspektor Gadget talks about that shift, and that's really exciting because that's what we also, as users, as consumers of Inspektor Gadget, that's also what we do. So we'll see that also in a bit. Okay, so let's go on, and then there's this section of how does it work, and it leads to an architecture document. So are you excited as I am? Because yeah, I am. Okay, yeah, let's go. So actually, those images are kind of outdated, but I'm here to walk you through all the different changes the projects have been going through. I know there is a GitHub issue to fix that part of the documentation. So no work. Don't be surprised if it changes in a bit, like changes in some time from now.
Well, let's share that issue in the comments so people can jump on it and make a first contribution right away.
Yeah, I'll share it in a sec. Once I'm once went over to Amit again. Okay, so we've got that kubectl gadget deploy, which actually installs Inspektor Gadget to your cluster. And since we want to collect events from all the different workers across the cluster, so it's actually deployed as a daemon set. So that's the installation process, right? And then when we do kubectl gadget trace, like starting a gadget, so it says that we created trace CRD, so that's not actually right. But what we do today is there is a gRPC server behind that does that for us, all this communication. I think there are only 2 gadgets left that don't use that kind of method. But what it does actually, is it's calling the Kubernetes control plane, and then like the gadget pod creates. We'll start a tracer. What does it mean to start a tracer? It basically installs the eBPF program, and now we're listening to events that are going like the events that we want to listen to. So if we dive deep even further. And before that, of course, like events are being streamed back to the user space where we can see them. So let's go a little bit, down. So over here, you can see the gadget tracer manager. Now that's kind of like the glue. That's what sits within your cluster. And what a gadget tracer manager does, it has a collection of the different tracers that we run, like trace DNS, trace exec, and whatnot. Like starts those tracers, stops those tracers, and so on and so forth. And on the other side, it has this container collection, right, where we keep data about the containers running within our system. And when we combine both of them, so we get that kind of like enrichment saying, hey, this event originated from that container, originated from that pod, from that namespace.
So is runc is the container runtime that is used? Is that only one, or because I know that we use some other
so that's
ones.
one bit of the documentation that is not very accurate. So you got me there. So yeah, there is this runc fan fa notify that I think that was like the legacy way to get aware of like containers that are starting or not. But today the default is to use eBPF. Actually, we're using fa notify with eBPF. To get all those containers that are being created on the system, and that's the way that we keep the collection up to date about the containers within the system. So yeah, that's a really good observation there, May. So and then again, the tracer manager also communicates through a BPF map with the eBPF with the gadget itself, and the gadget itself also sends all those events through the ring buffer, just as Amit explained. So that's the way it works. I think it's really neat. So I think also a really good way to understand Inspektor Gadget is by learning about how we use that in our day-to-day, right? Amit, what do you say?
We want to see examples.
Yeah, let's do that. So I think Kubescape is a good example for that. Let's see that.
Yeah, so thank you, Dor, for the detailed explanation. So we are big fans of Inspektor Gadget, and we use them a lot. Basically, most of our eBPF-based tooling is Inspektor Gadget. So a quick introduction on Cubescape, and then I'm going to show you how we use them. So Cubescape is also a CNCF project. We're soon going to be incubating, hopefully, and you're more than welcome to give us a star. We're just hitting 10K now. It's really exciting. And Cubescape, basically, it's a tool that you can install in your every step of the way, from the left to the right. It can run at code, on CI, and even on the deployment, for example, inside your cluster, where the true power of eBPF and Inspektor Gadget kicks in. And we have a lot of fun use cases for them. So let me just dive into the code. So one piece of Cubescape is what we call the node agent, which is the agent that is being installed the same as Inspektor Gadget, deploys themselves as a daemon set on each node of your cluster. So also we install this node agent. And as Dor explained, the magic that Inspektor Gadget gives us is that it allows us to enrich containers, or enrich eBPF events with container and Kubernetes context. So, for example, we have this container collection piece of code, and here you can specify which enrichments you want. So, for example, we want to know when a new container is being started, and as Dor said,
Amit, any way you can zoom in a bit? I see May squinting her eyes.
Yeah.
Oh yeah.
I'm not
And
blind.
since
but that
she
was
has,
okay.
no, we know you're not blind because you caught that runtime thing before. So this means we need a zoom in for everybody.
Thanks.
Okay, so now it's too zoomed for me. Okay, now you see it better?
Perfect, thanks.
Okay, so again, we have this container collection. Here we specify which enrichments do we want. We want to get new containers. We want to also get the OCI config of those containers. We want to get Linux namespace enrichments, for example. And we want to get notification whenever a new container is getting started. And once we initialize this connection and this enrichment of the container collection, we basically can initialize the what we call the tracer manager. So the tracer manager is the one in charge for starting the different traces. So for example, I want to know on every exec that is being performed on the system, basically every new process. So I have this exec tracer right here, and I initialize it with the container collection. So if we go a bit back to the code, and we skip all the not interesting part, you can see this line. So you have tracer collection, which basically creates a new, let's say, the one managing all the gadgets, all the tracers, and we are passing the container collection that we've initialized in the previous snippet. Once we have that, basically every single event from eBPF is going to be enriched with the Kubernetes context. And for us, which we are a very Kubernetes context aware tool, and we're focused deeply on Kubernetes, this is amazing because they saved us so much heavy lifting and work to do. And from taking eBPF as the, I'll say, not very smart mechanism that just gives us events from the kernel, into actually giving them a lot of context. And this is where we also see that Inspektor Gadget is like, it's more than a debugging tool, it's like a framework, and it's amazing. So I think that's enough of code for us today on Cubescape. And Do, do you want to take it?
Yep. So actually, you mentioned runtime threat detection and stuff like that. And in Defender for Cloud, we recently announced this really cool feature about detecting binary drifts. So like where container images are immutable, right? So if something changes within a container, like a file was created and someone tried to execute that file, that's a problem, right? So we actually use Inspektor Gadget to do that kind of detection. And that's really like that's one use case. We're also using Inspektor Gadget to create that kind of detection. So what I really want to say that like the message here is Inspektor Gadget does not only give you the way to start all those different gadgets, but also gives you all those functions that were built from the experience of people who use eBPF. Stuff like is this file was created in the upper layer of the container image. Those are really convenient to use, right? So it's also about actually helping you writing those gadgets and not only like bundling them up and so on. So like with that, let's move to our last demo. I think right before we wrap up. When I was thinking, what kind of gadget can I write, right? Like, what kind of gadgets can I contribute to the community? So, and I'm a security persona, right? Like, I'm working in the security space right now. People keep asking me about hardening your container images. I keep hearing that question over and over again, and like the obvious answer to that is, hey, yeah, make sure you build your container from scratch or from digitalized and so on. Make sure you don't have all those unnecessary dependencies within your image, because that's the way like the attack surface is bigger, right? And the example they give you is, why should you have shell in your container, right? So I took that really small anecdote, and I said, let's build a gadget around that to show that there isn't a hybrid approach to that, right? Like, you can have shell in your container, but you cannot use that unless you were explicitly allowed. You were allowed to use that. So that's kind of like an hybrid approach.
Because sometimes you do need that shell.
For this case, but I think it's a really neat one.
I mean, sometimes you do need that shell in you do want that. Like, you just want to change something small or to test it. But I know it's not the safest thing. And when you said, "Oh, I'm into security," I was like, I know, but listen, it's like just one little thing. So now I'm intrigued because you said, okay, I have a hybrid approach. So okay, I'm listening.
So let's
and Dov, I think you're being too humble, because this is really not trivial. Like talking about this. Granting too much access or not granting enough access, like this circus balancing act. It's something that's not trivial at all, and it's really cool that you've built an agent to resolve that, and especially coming from a security space.
Yeah. So, well, like there are ways to block interactive access, right? You could block the exec the -it in your Kubernetes cluster. But like that's an all or nothing kind of thing. And once again, I was looking for the hybrid, right? Like I want to give you shell access only if I allow you to do that. So that's what I really like about that example. Maybe I can productize that, but I think that like as a story to tell about building gadgets, I think it's a really nice story to tell. So let's share my terminal again. So I have this this gadget project that I built, right? And you're probably interested in seeing what a gadget looks like, what this eBPF code looks like. So let's really quickly have a peek at that, okay? So as you can see over here, right? What I'm doing to actually identify those interactive shell requests is by listening to this specific IO control system call. And what I'm looking for is someone who tried to start a pseudo terminal, right? Like requesting the pseudo terminal device. So I won't jump into all the code, but whenever I see that kind of process execution, a process trying to call that IO control system call, I will instantly kill that process. Okay, it does not kill the container, but it only kills the process itself. As I mentioned before, I did not, but the Inspektor Gadget folks built kind of like a Docker CLI experience and they see gadgets as kind of like, like containers, right? When you build your own gadget. So that's really cool because you get to actually work as if it was kind of like, well, it is an OCI artifact, right? So you can build it, you can tag it, you can push it to your registry, and then you can pull it and run it in your Kubernetes cluster. So that's really cool. So if you look at my make file, you'll see that my build command is actually a one-liner saying IG image build, right? And what it does is it's going to build my image. Okay, so let's do that. So let's do make build, and now my image is built and it was tagged with my remote registry. I can tag it if I want. Like, let's say I want to change the tag from that dirty tag to stable, for example, right? So let me just copy that for really quickly. So I would use something like, now I'm using, by the way, the IG binary to do that. So don't be, if you're still, that I was using kubectl gadget a minute ago, that was to interact with my cluster. But now since I'm building images, so it's easier for me to use the binary. So I can use image tag, which is pretty similar to Docker, right? So, and then I'll just take my, yeah, of course, it would do that. And yeah, that was because I was in Hebrew, tough language, the language of the Hebrew man. So let's do that. And instead of calling it dirty, what I'm going to do is I'm going to tag it to, hopefully I'll do that quicker. I'm going to tag that to stable, for example, right? Interactive, stable. And now that my image is ready, what I'm going to do is I'm going to push that to my registry. So it would be pretty much the same, IG image push, and I'll push the stable version. And as you can see, it pretty much acts like, like as if I pushed my container image. So now that I have this image available for my cluster to pull, I can actually use that. Okay, so for a second here, I'm going to exit from the bash from before. We'll use the same Ubuntu, same trusty Ubuntu. And now what I'm going to do is I'm going to do kubectl gadget, and I'm going to use the run command. Okay, so what you see over here, I passed the -- verify - image false flag, right? And that's because Inspektor Gadget by default verifies the image signature, and I did not sign my image. But the project does that because we want to make sure that the gadgets that we're running are actually signed and wasn't tampered with. But since we just a demo, so we did not sign that. And let's start that gadget. So it's running and it's listening for like eye control events, right? And what I'm going to do now is I'm going to do this kubectl exec bash again, and surprise, surprise, I cannot. Okay, I cannot. If I want to do something that is non-interactive, if I delete -it, right, and do bash c echo lo, so that's going to work. Like, I do not block those kind of commands because I block only interactive access. If I were to stop the gadget, right, and to start an interactive shell again, there we go. I get a shell. So you see, like I use Ubuntu. I can start an interactive shell with that. Yet, sometimes I cannot, sometimes I can. And I see how can I extend the use of that gadget to create like some kind of a system that allows you to get interactive access, and sometimes it does not. And that's what I think really neat about building gadgets, right? You get that really complex functionality, and you do that really quickly by using eBPF, and then by shipping those in a really easy manner to customers, right? You can also see some of the community gadgets at Artifact Lab. Maybe I can share a link and explore those. But yeah, I think it ends here. Hopefully, hopefully you get some understanding of what Inspektor Gadget is. Yeah, May, go ahead. Sorry.
Okay. as you can see, I'm very into it. So I have a lot of questions, and I'm smiling because I'm excited to hear all those things. So, yeah, I have, my question is, let's say I want to get started. I want to look into Inspektor Gadget. I've never seen it before. It's amazing. It blows my mind. And you showed us the list of gadgets, right, in the GitHub repo. Do you have like a few recommended ones that you'd say, here, if you want to get started, or these are like the better ones to start, these are the basic ones that you want to go and look around, and then you can take it from there or whatever, but these are good ones, always useful something.
Yeah.
I'm asking for someone else, obviously.
Yeah, of course. So the gadgets I find myself using the most are the ones that we use as part of the product process exec, like trace exec, for sure, right? Like as I mentioned, but also for personal use, trace DNS is really amazing. I also really like the trace loop gadget. It gives you kind of like an strace output, so that's something that I find really useful. I would also say that there's a really big interest around SecComp recently. So the advice SecComp profile, which generates a SecComp profile by listening to your container. So that's also a really neat feature. Also, I think Amit mentioned the generate network policy, right? So that's also a very good one. So these are my favorites, my personal favorite.
What? Network policies?
Yeah. We can generate like listen to your container, see like what kind of communication it does, and then generate a network policy which you can use in your cluster to make sure that that container does not like drift away from its network policy. So these are really useful. I think the advice ones are really cool. They have their caveats, right? But for most use cases, I would say they work well, from my experience.
Okay, so it's a very good detailed answer. I should have written some of those down, but maybe you will write those down for us in the comments later or something. I'm giving you homework already.
Yeah, I'll do that.
Yeah, if I can add on top of that, is that for me, like, and that what I've experienced with talking to other people is that a lot of the times people just want to see what's going on, what requests each workload are doing, and the network policy and SecComp profiles are the greatest example for that. It's like it's almost impossible to generate them manually, and the fact that you can just with one command install Inspektor Gadget to your cluster and get that visibility over almost anything, files, processes, networks, system calls. It's a very powerful tool, both for DevOps and both for security, and it's like a toolbox for anyone who wants to do anything inside a Kubernetes cluster.
Yeah, and I think that this is one of the, I guess fear is a big word, but like those were the things that I wasn't sure about, like how am I going to do that in Kubernetes, things that I was able to do when we worked with VMs. And it's good to know that there are many different solutions, and this one sounds cool and easy enough to use, which I'm in.
Me too.
Yeah. So yeah, I hope you enjoyed that deep dive, and it was deep enough for you. I certainly did.
I think we all did, and we learned a lot about the project and eBPF in general for those who are new to the field. I want to ask you a question about the future. So you said that Inspektor Gadget is evolving into a framework, and it's getting a lot of traction, and it's all very exciting. But where do you think, if you had to envision, in your wildest dreams, Inspektor Gadget in 2 or 3 years from now, how do you see it? How do you see people using it, or what types of new capabilities you can imagine being rolled out in the future?
Yeah, I have an idea for that. Like I imagine the way Docker and images got such a big momentum. Like I imagine that we're going to have such a big like a registry of eBPF programs that are ready to use. Shipping eBPF as OCI images is like it's amazing. Like Dor works at Microsoft, I work at ARMO. We both use Inspektor Gadget, and Dor is building some gadgets, putting them as an image, and I just use them in my product and to my needs. The same as I do a Docker pull, so I just pull this eBPF image, and I expect this pool of images and options and gadgets are going to get so big that everyone is just can use eBPF in their day-to-day so easily without the need to really dive deep into writing eBPF and knowing the technology. It's going to be the same as Docker for me.
Yep, I think we're pretty much aligned on that vision. I would like to see the community, creating more gadgets and Inspektor Gadget enabling the community using others' gadgets, right? And we have like this really huge registry of really cool gadgets that we can use. And as eBPF evolves, right? So I think like the new use cases keep on popping around. So there's certainly like a really promising future for that project, and I think that jumping in early on would we'll make sure that you will be on track to see how it is actually evolving. And like creating those kind of like gadgets, like I just showed I think a few minutes ago, that's really cool. I want to see others contributing theirs. And like collaborating. Also, like the CNCF landscape is all about like collaboration and people contributing from their time to help others with similar problems. And I absolutely love that. And I see how Inspektor Gadget like expands that kind of vision for the eBPF landscape itself. So that's my take.
Incredible. So unless we have any more questions from the audience or from May, if you have something else you want to know about.
I'm done, I promise. But it was very interesting, and I enjoyed learning about that wonderful project. Yeah, thank you guys for joining us today.
Thank you, May, Udi, Amit. It's been a pleasure.
Yeah. Thank you both for sharing your knowledge and experience, and thank you, May, for co-hosting this with me today.
Woo.
And thanks to everyone who tuned in and is watching this now. We hope you learned something new or already eager to contribute to the project. We shared the repo in the comments, and also that issue that Dor mentioned earlier with the architecture diagram. So you are more than welcome to jump on that as your first issue in Inspektor Gadget, and hopefully, thanks to this live stream, more people will engage with the project and build more and more agents, and will bring forth the future that you have both just illustrated for us. So thanks again, everyone. Thanks for all the comments popping here. So yeah, obviously people enjoyed it, and we'll see you next time. Bye.
Bye.